Hi, this video is going to carry on and it's going to be page 14 in your booklet, and we're looking at hydrolyzing polyesters. So I've got a polyester drawn here, and what we're going to do is we're going to split it through hydrolysis, which means we're going to add water. And we can do that two ways. One is with base hydrolysis, and the second way is with acid hydrolysis. So in the top column in your notes, in your booklet, you're going to have to draw this structure down. And the first thing we look at is base hydrolysis. This will go into the bottom left-hand column. Now, base hydrolysis involves sodium hydroxide with water, so aqueous sodium hydroxide. And what happens with this is we cleave the ester bond. So that goes back to how it was. So we get our benzene ring with our carboxylic acids. Now, normally you'd expect the H's to go on here. So to get a H there and a H there. But because this is in a base, sodium hydroxide, and these are acids, they're going to form the carboxylate salt, and we're going to get Na plus and Na plus on here. So we get ionic bonds forming there. That's because it's in basic solution. So there's going to be lots of OH minus around when you're in a base, and the hydrogens are going to prefer to join with those OH minuses to form water than stay on the carboxylic acid. The alcohol side of it, that will just revert back to its original alcohol or diol that was there before. So we'll get a carboxylate salt or a dicarboxylate salt plus a diol when we do base hydrolysis. Acid hydrolysis, slightly different. So this time we're going to need an acid, and again with water. And what happens here is we'll get the carboxylic acid. It's in acidic conditions, so it will become the carboxylic acid, and the diol. So both will form the diol back that we get from over here. So the diol's just there. And both will also form a carboxyl group. This will be a carboxylate with a salt because it's a base. This though, because we're in acidic conditions, will just go back to being a carboxylic acid. So we'll go through some of the conditions here. It's hot, aqueous HCl. It's slow, and we get alcohols and carboxylic acids. Over here on this side, it's with hot, aqueous, and NaOH. It's fast, and we get alcohol again, but we also this time get the carboxylate salt, not the carboxylic acid back. The hydrolysis of amines and amides, slightly different. Sorry, hydrolysis of amides. You're not going to hydrolyze amines. If we have a look at the structure we've got in your booklet. We've got this nice polyamide. So amide bond here. First up, if we do base hydrolysis, so hot aqueous NaOH, we are again going to form a carboxylate salt. Just make sure they're all in the right positions. Up here, we've got 1, 2, 3, 1, 2, so it's 1, 3. That fits. Plus, now we're going to get an amine forming. And amines in alkali conditions will be NH2. There is a chance they can accept protons, but there aren't going to be too many protons floating around in an alkali solution, a base solution, because the OH minuses that are floating around when you have high pH will take all the H's before NH2 is going to be able to get them. But in an acid solution, something slightly different happens. So if we have H plus H2O, so in an acid solution, hot aqueous acid again, we're going to get our carboxylic acid back. But our amine now, because in an acid solution there's lots of H pluses around, our amine is going to take on a hydrogen to form an ammonium ion. So we'll get NH3 plus down there on each of those. This is because in acid solutions we have lots of H pluses all floating around in this solution. And NH2 acts as a base, it's a proton acceptor, so it's going to take one of those on. So products in this is going to be hot aqueous acid again, we're going to get our slow, but we'll get the ammonium salt forming down here, plus our carboxylic acid up here. On this side, we'll get the carboxylate salt and an amine forming down there. So let's have a look at page 15 now and identifying the monomers. So the first one to identify has CH3, CH3, H, CH3, H, and it continues OH, H, OH, H, OH, H. So we've got to try and identify what type of monomer is in here and where the repeat unit is. So you probably see up here along the top, it goes CH3, H, CH3, H, CH3. Along the bottom, H, OH, H, OH. So every 2 we've got here, it repeats itself. So that's our repeat unit. We should also notice that there's no ester bond, there's no amide bond. We've just got a straight chain of carbons all the way along. So the first thing to go is the type of polymerization we've got here is addition polymerization. We're adding on, you should have seen this from first year, where you did addition polymerization. Next then is identifying the repeat unit. So we've got our C with a CH3 here, then down to a H, and C, then H, and down to an OH. These 2 bonds that come off the side, they have come from the broken pi bond in the centre on the double bond. So that will be our repeat unit. Might draw the skeletal version like that. So it's a case of identifying where the repeat unit is. We can tell it's addition because it's just a straight chain of carbons. And then take the repeat unit, where there were bonds going out to the side, get rid of those and put that linking the 2 carbons in the centre. The second one, slightly different. So in this one, we have got a ester bond clearly visible. If I draw this out quickly. Didn't quite give myself enough space there. So clearly got an ester bond here. So the type of polymerization we have here, an ester is a condensation, or a polyester is a condensation polymer. We've had a condensation reaction to form these polyester. Then we can also probably see there are 2 repeat units here. We've got the alcohol group, or diol group, here, and then here will be our carboxylic acid group. So our C, C, H, 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 this was to the single bond into an O side of the ester. So that will be our alcohol group. And this one was into the carbonyl side of the ester. So that will reform as our carboxylic acid group. And here we have 1,2-ethanediol and butandioic acid. So if we compare the characteristics of the types, we've got addition. Addition have their monomer will have a carbon-carbon double bond. They will also, their polymer backbone will be carbons, or a continuous chain of carbons. So you saw that in the first example the top of the page, that work example, it's a continuous chain of carbons forms the backbone. Condensation polymers will have either one monomer with two different functional groups, or two monomers with two functional groups on each. And you saw that in the second example. The polymer will contain either the ester bond or the amide bond. So either of those two will be in there. And that is the page 15. So page 16 is questions for you guys to try. And good luck. You can rewind the video. There's also the PowerPoint that will be attached to a file sent to you.